So, we are going to discuss about Newton's law of gravitation. What is Newton's law of gravitation? Newton says that every body in the universe attract other body with force, and this force is directly proportional to the product of mass of these two body, and this force is inversely proportional to the square of the distance between these two body. So if we consider here, this is the one body and this is the another body. This body has mass m1 and this body has mass m2. Now consider the distance between these two body is r. So according to the Newton's law, this both body attract each other because of its mass, and this force of attraction is directly proportional to the product of these masses. Okay, so F is directly proportional to the m1 into m2, and this force is inversely proportional to the square of the distance between this body. Now if we give this equation as 1 and this as 2, if we combine both this equation, then F is directly proportional to the m1 into m2 divided by r square. Now here we see that there is proportionality sign. If we want to remove this proportionality sign, then we have to put some constant of proportionality, and here one constant of proportionality comes in play, which is g, and this g is called as universal gravitational constant. So this equation becomes g, F is equal to g into m1 into m2 upon r square. Here the value of g equals to 6.67 into 10's power minus 11, and the unit of this g is Newton meter square divided by kg square. So this is our Newton's law of gravitation, which states that every body in the universe attract other body because of its masses. Now we will derive the unit of this gravitational constant and also derive the dimensions of this gravitational constant. So we have derived the formula here, and from the formula we will derive our unit and dimensions. So first of all, we will derive about unit. We know that what is the gravitational constant g, okay, is equal to 6.67 into 10 to the power minus 11, and we know that our Newton's law of gravitation, force F is equal to g m1 into m2 divided by r square. So we can write as g equals to F into r square divided by m1 into m2. We know that in SI unit, okay, in SI unit F is written in Newton. Here r, which is the distance between our two masses, it is written in meter, so it becomes meter square, and here the mass, which is in SI, written as kg, so it becomes kg square. So this is the SI unit of our universal gravitational constant. Now we will derive the dimensions. We will derive the dimensions of g. We have derived here SI unit, which is Newton meter square divided by kg square. We know that Newton, which is unit of force. Okay, force, and force is equal to mass into acceleration according to the Newton's second law. So mass is written as in kg and acceleration is meter divided by second square. So kg is written as m, and here is mass, so mass is written as in L, and here second square, so here we write as T minus 2, okay, T's power minus 2. So this is the our dimensions of force. We will put here, we will put in the unit of our G, M, L, T minus 2. Here meter square, so in place of meter square, meter is in length, so we will write here L square. In divisor there is kg square, so kg which is for mass, so we write as mass square, okay. And if we will solve this, then the finally dimensions of G is m inverse L cube T minus 2, okay. So this is the dimensions of G. So this is all about our Newton's law of gravitation. We have derived the what is the formula, what is the SI unit, and we have also derived the dimensions of G. Thank you very much.